Hello everybody. In this video we are going to walk together and create our CAD file for our part 5 for the engine case in our model engine. To be able to do that, we need to start by opening up Fusion 360 and selecting our working folder. So to select your working folder, we want to click on the Show Data Panel waffle in the top left hand corner. We'll click that. And if you don't have any folders or any projects in here, what we need to do is we need to select a new project. Once I select my new project, I'm able to rename it. And so I will just rename this one as our example. And when I'm ready to create and save my part, I want to be inside that folder. So we'll double click in there. And when we save, we'll be able to be right inside that folder. So I'm going to name this 05 Engine Case, and we'll save that. And while that's saving, what we would like to do is we also want to double check and make sure that our document settings are in inches. So to be able to do that, I click on the little triangle there. I see that my units are already in inches, but if they start out in millimeters, what I can do is I can change it from that millimeters to inches, and then I can set that unit of measurement as a default by clicking that little checkbox inside the set as default. Then you press OK and you're able to get out of there. The next step that we need to do before we draw this is we want to make sure that we are using aluminum as our material. So I'm going to right click on that name in my browser, the 05 Engine Case, and come on down to our physical material. We'll click that, and you should get another window that pops up. And right now we are going to be drawing in steel, which is just fine for modeling, but when we are calculating the mass of our part, we want to make sure that it is as close as possible to the part that we're actually going to be making. So down here in our library, I want to select metal, and the metal that we are going to be using is 6061 aluminum. So we come on down till we find the aluminum with our 6061 alloy designation right there. Be sure not to select the cold formed, hot formed, or any of the other ones, but we just want to click and drag the 6061 aluminum over on top of the steel, and when you release it, it should replace that, and we'll hit close. Now, to start out, make sure that we have access to our prints, either a printed out version or the one that you can find online. And we're going to continue to reference this print as we go through it. When I create my part, what I'm actually going to do is I'm going to use the origin on the top left-hand corner just as the same as I would for our work coordinate system. It'll make things a little bit easier later on when we start making our tool paths. But know that if you do select your draw so that your origin is down here, we can change it later on. It'll just be a little bit easier in the long run if we have our origin in the top left-hand corner for our work coordinate system. So to read the print, a couple of vital measurements that we have is from this dimension right here is going to be 0.9375, which we can find on this view right here. Overall width is 2375, which we can find over here. And then the overall height of this part is going to be 1.4, which we can find on this view right here. A couple other features that we're going to note for this first process is we have a radius of 0.25 inches for our fillets right here in both this side as well as that side. So let's go back to Fusion and start to create that. To be able to create our first sketch, we need to click on Create Sketch, and you're going to see your origin. Now you have your Z in blue, your Y in green, and your X in red. So like I said before, we want to make sure that your work coordinate system or your origin is going to be on the top left corner of our part. So I'm going to create this sketch from the top down. I want to select my XY plane. And when I make my rectangle, I'm going to select my first corner at the origin, and I'm going to go down into the left. When we are moving around our window, if we scroll up on our scroll wheel, it'll zoom out. When we want to scroll in, we scroll down, it'll zoom in. If I click and hold down my scroll wheel, I'm able to pan. So if you see me moving around, that's how I'm accomplishing that. When we are entering our dimensions, we can select, or we can toggle between our two dimension boxes by pressing Tab on the keyboard. And from our print from before, I'm going to enter 2.375 in that box right there. Hit Tab to go down, and this dimension is 0.9375. We'll hit Enter. Now we have a properly dimensioned rectangle. The next up is we want to add those two fillets. So I can either select my fillet tool right there, or I can click on Modify and bring that down. And then I can select Fillet up on top. And I'm going to select that fillet, or that corner and that corner, type in 0.25, hit Enter, and that changed both of those. Now we're done with our sketch. We need to select Finish Sketch. And I'm going to click on Extrude. And remember, we want our work coordinate system in the top left-hand corner here. So instead of typing in the 1.4 and having my extrude go up, I want to go down 0.14 so that my origin is still in this top left-hand corner, kind of like it would be when we put this in the mill. So in my box here, I need to type -1.4 and hit Enter, and now we have the beginning of our part. The next thing that we have on this top are these two holes right here. These are going to be right in the center of that fillet, so 0.25 in as well as 0.25 down. And both of these are 1032 holes, threaded holes that are 3/8 or 0.375 going down. We'll go back to Fusion. And a quick, easy way to do this is select the hole tool from Fusion. And what we want to do is we want to select this top face. And you'll see that we have a hole already put in. So once I have my hole put in, I'm going to select my first reference, and it's going to be this side. And from what we saw in the print before, we'll type in 0.25. My second reference is going to be off that top edge, and that's going to be a 0.25. And then what I'm going to do is I'm going to do it's a simple hole. A hole tap type is going to be tapped, and our thread offset is going to be full, and my drill point is going to be an angle. So we come on down. On the print, we had that it needs to go down 375 thou. So the extent's going down. I'm going to type in 0.375. 118-degree angle looks fine. I'm going to scroll down on here, and what we are going to find is under the designation, we have a whole bunch of different types of taps. Unfortunately, these are all 13/16. To be able to change that, we can go up to the size, and what we'll end up doing is we'll look for number 10. So you may need to scroll up or scroll down, and once we find here, our number 10 is actually 0.19 inches. So, and I know it's number 10 because it's labeled as such. So it defaults to 1024, which is your Unified National Course thread, but we actually want 1032, which is UNF. So we're going to select that. It is 3B, right-handed, and you press OK, and there we have our threaded hole already put in. So what we're going to do is we're going to repeat that a second time, except it's going to be over here, and it already drug in all of our stuff, except this needs to be 0.375 down, and our references need to be that 1/4 inch from the side, as well as the 1/4 inch from the top. Double check. Oop, accidentally scrolled on that and messed that up, so I'm just going to go back and manually select that, 3D, and that looks good. that. Let's go back to the print and figure out where our cutout there is. So we have our cutout right here, and we can see that the center of this circle is 1.1875 in from the side. It has a radius of 0.6875, and it goes down from the top 0.625. And we have these two vertical lines right here, which are tangent to that, and it is cut a 1/2 inch thick. So we'll go back to Fusion 360, create a new sketch, but instead of being on the top, we're going to be on this face right here. We'll draw it on that face. I'm going to start out with my center diameter circle. I'm going to come on in. If we bring it close to the center of that, you may see a little snap where it pops on there and you get a little blue dashed line. I'll click and drag out, and I'm going to type in a diameter of 1.375 for that. And then what I'll also do is I'll start by bringing my two vertical lines in there. So I'll start with a tangent and I'll go straight up. Same thing on this side. Tangent going straight up. And now what we get to do is we get to dimension where that is exactly. So I'll select that center point for my circle, select the side right here, and that has a dimension of 1.1875. And then what I also need to do is I would like to select that center point right there, select our top horizontal line, and that is going to be a dimension of 0.625. All right. The last thing that I want to do is I want to make sure that these vertical lines are tangent to that. So I select my tangent constraint, which is a little circle with a straight line next to it. I select that first line, select my circle, then I'm going to select the second line and also select that circle. The last thing I want to do is I want to trim off the top half of our circle. And to be able to extrude it effectively, I'm going to select a line in my create, and I'm going to make that line from that first point over to our second point, select finish sketch, and now according to our print we're going to extrude, select that face right there, and I'm going to type in -0.5, so it's going to go back that way, and we want to make sure that we have our cut operation selected. What that'll allow us to do is remove the material rather than add more material. So then I'll select OK, and we now have our little cutout there. The last thing that we want to do when we look at the prints on this operation is we have these top holes right here, which are 0.25 or 250 thou from the top going down there, that are also measured 1/4 inch in. And then also these threaded holes right here, which are 0.7 or 700 thou going down right there, and they are also 1/4 inch in as designated by that dimension right there as well. These threaded holes are 1/4 UNC 3B, and they are threaded 1/2 inch down. And then these holes right here are 1/8 inch or 125 thou, and they are drilled down 0.1875. So let's go back to Fusion and put those in. So I will create my first hole, and it's going to be done on this face. And for my reference, my first reference, I'm going to select from that top, and again that's that 0.25 that we saw earlier. My second reference is going to be from this side right there, and again that's going to be 0.25. And the hole type is actually going to be a countersink, because it says that we have those holes that need to be deburred, which is going to be just a very, very tiny countersink. They're going to be, those edges are just going to be eased and broken, and it's just going to be 10 thou. That is not going to be a hole tap, so it's just going to be a simple hole. And for our drill point, we're just going to use that angle. The depth per our prints is 0.1875. The width of that is going to be 0.125. And on our countersink, what we're going to do is we're just going to break those edges 10th out. So we're going to take that 0.125 plus 10th out, which is 0.135. And then we press OK. And we have your first hole right there with the edges already broken. So let's repeat that process over on this hand side. It's going to be roughly the exact same. The only difference is that our reference points are going to be off this edge of 0.25, as well as the top edge right here at 0.25. Just double check that we are going to be doing a countersink or break those edges. We have a simple hole tap, meaning that we're not threading anything. It's going to be a angled drill point. The depth is 0.1875, which may round up to 0.188. The overall width is at 0.135, and that's for your countersink that we broke those edges, and then the diameter of that hole is 0.125. So we'll press OK, and now we have that hole in there as well. The next thing we're going to do is we're going to put in 2 more holes on the bottom here, and that's our 1/4-20 tapped holes. So I have my face selected. My first reference is going to be off the top, and again from our prints that is 0.7 down. Our second reference is going to be from the side, and that is going to be 0.25 in. For this one, we are going to be doing a simple hole. The hole tap is that it's going to be tapped. It's going to be a full thread. The depth of this, on the prints it states that it needs to be a 1/2 inch down. So I'm going to highlight that and type in 0.5. And we're going to come down a little bit further, and the size of this, we can scroll down until we find the 1/4 inch, which is 0.25. And this is a 1/4-20 UNC, and our class is 3B. And then what we'll do is we'll press OK, and now we have our threaded hole right there. We'll repeat this operation over here. Select that from the right hand side, that is 0.25 for that reference. Second reference from the top is going to be 0.7, and then all of that checks out. It's the same as before. It's 1/4-20, class 3B, right hand, press OK. And there we are finished with our part. If you wish to orbit your part around, what you can do is you can hold down Shift on your keyboard as well as clicking and holding down your scroll wheel to be able to find that. Now, if we would like to find out and see if our weight and our center of mass is the same, what we need to do is we need to right-click on the name of our part, kind of like when we change the physical material. But what I want to do now is I want to go down to Properties, and I'll select Properties. And what you'll see is you'll see a window that pops up. And the mass of this part is 3.474 ounces. And it has a center of mass that is 1.188 in X, negative 0.395, and then we have negative 0.743 in our Y and our Z. If you don't have that for your ounces, for your mass, the first thing to check is double check that you're using aluminum. The second thing to check is you need to make sure that all of your dimensions are done properly. If you don't have it set as aluminum, or if your holes or cuts have the wrong dimensions, then your mass will be off. What our center of mass calculates is the actual hole placement. So if we have a hole that's a little bit different, you'll have your center of mass in a different area. So when you're done with that, check your weight and your center of mass. We want to double check that we save. And then what we need to do is we need to double check with our instructor that we can move on to our tool paths in the next video.